hello statistics students. Welcome to week 5 of our Basic Business Statistics course. I'm Todd Daniel, your instructor, and today is a cold and icy day here in the Ozarks. The university has canceled classes. No problem. I designed this course so we could go fully online if we needed to, and that's what we're doing today. I am doing this lecture from my home office. You can see I have one of my co-workers with me who's just been hanging out and being a very good dog. So I'm going to put you back in your dog bed right there, and we are going to get to work talking about location and variability in statistics. Now, I started last week with our lecture talking about there being 2 questions that we want to know, especially when we're looking at categorical data. And I said those 2 questions were, we want to know what is the total number of scores, and we want to know how many subgroups there are, how many scores are in each subgroup. So it's the question of how much and how many. But when we're describing distributions of scale level scores, there are 2 different questions that we want to ask about that data. The first question that we want to know, as we are considering a distribution of heights or of weights or of time measures, is what number is at the center of that distribution? In other words, what number is the best representative of all of the other numbers in our distribution? The second question that we want to know is how spread out are the scores in the distribution? Are they tightly packed together? Is every score pretty much like every other score? Or are those scores all over the board? And there are high scores and low scores, and any score that you pick is going to be different from most of the other scores. That is a question of spread or variability. Our 2 questions, therefore, are central tendency. Where does the center tend to be? We'll also call that a measure of location. And spread, which we will call variability. Let me then define what is central tendency. Well, like it says on the tin, central tendency is where the center of the distribution tends to be. And what that does for us is to answer a general question about whether the scores are universally high or low. Where do the scores generally tend to be? If we're considering a distribution of heights, for instance, what is the average height for the players on our high school basketball team? Now, we know that basketball players tend to be taller on average than most people. And so the height, the average height of our basketball players might be something like 6'4". Not every player is exactly 6'4". Some are taller, some are a little shorter than 6'4", but overall, as a group, that average score is going to be higher than what we would typically find. If we were talking about horse jockeys, their heights are going to tend to be shorter than what we might typically find in the American male population. Maybe a score somewhere around 5'5". When we look at these 2 distributions of height, we see that one is generally high, the other is generally low. If we were to measure the average height of our chess team at school or the average height of the band, probably going to get numbers that are more similar to the overall population heights. One thing that's important to remember, though, as we look at central tendency is the distribution, the variability, can include either outliers or just scores that are normal but are part of that distribution. For instance, if I tell you that the average height of basketball players is 6'4", you might say, yes, but I know of a basketball player who is closer to 5'6". Well, that may very well be true. There may be an outlier in that distribution. There may be someone who is different than the typical score. But we have to remember that on the average, the whole group tends to be around the mean score, even if we have variability or we have outliers in that distribution. Now that I've defined central tendency, let me define variability for you. Variability indicates how spread out the scores are. The word that we use in everyday life to describe not so much variability, but the inverse of variability, is consistency. Consistency is the opposite of variability. If there is high variability, there is low consistency. And when scores are very consistent, we would say that they have low variability. Well, let me give you an example of this. Let's say that we decided to go on a road trip, and along the way, we decided to stop at all of the McDonald's restaurants that we passed. You guys remember road trips? Man, I miss road trips. So let's say that we have some friends, we've all been vaccinated, maybe this is a few years in the future, we can go on a road trip. Do you expect that the quality and the taste of the hamburgers that we get as we stop at McDonald's restaurants across the country, is that variability going to be high or low? Well, the answer is that we will get very consistent results from these burgers. Variability will be low and consistency will be high. Every burger is going to taste just like every other one. Now that's the variability. There is not going to be much difference from one place to the next. Very consistent. We tend to like consistency. If you are looking for a great burger, you might choose a different restaurant that you think has consistently high quality, or you might know of another place that you think has consistently low quality. But either way, we can count on the quality being the same any time that we eat there or at any restaurant that we choose. On the other hand, if there's a restaurant that sometimes is great and other times is awful, we tend to not like to eat in a place like that because last time it was good, you're hoping it's going to be good this time, it's not, you just don't know what to count on. In real life, we like consistency and we would prefer to have low variability. Now in statistics, we get what we get. So let's look at the way that variability and central tendency work together. The greater the variability, the less accurately that the data are summarized by a measure of central tendency. In these two distributions, they each have the same mean, but they have different measures of variability, which we're going to call standard deviation. On the left, we have a large standard deviation. What you see is that these scores have high variability, and therefore, if you were to pick a score at random from this distribution, it may be like the other scores, it may be quite different. We have low predictability when we have high variability. On the right, with a small standard deviation, the scores are very close to each other. We have low variability, and that means we have high predictability. If you pick any score from this distribution, it is very likely to be close to the mean because all of the scores are close to the mean when we have low variability. We're now going to explore three measures of central tendency: the mean, the median, and the mode. We're going to begin with the mode, which is the most frequently occurring score in our distribution. When we have a normal distribution or just a typical distribution, the distribution has just one mode. We see that because there is one peak in the data. That is called a unimodal distribution. That is the expected distribution. Now, sometimes we would have two modes, two peaks that occur, and that would be a bimodal distribution. So we might wonder, why would we have a bimodal distribution? And there are two common reasons why bimodality occurs in a distribution. The first would be when there really are two modes. Let's imagine that we decide to get away for a while and we go up to a secluded fishing joint where we can just enjoy the weather because it's warm out, and we can fish early in the morning, late in the evening, whenever we like. So the question would be, when would we catch the most fish? And the answer would be, we're going to catch more fish first thing in the morning when we go out at dawn. During the middle of the day, we're not going to catch too many fish, especially when the sun is out, it's very warm. But in the evening, when it starts to cool down again toward dusk, we're going to see an increase in the number of fish that we catch in the evening. There really are two modes. When are you most likely to catch fish? First thing in the morning and then in the evening. Another time in which we might have a bimodal distribution is when there are overlapping distributions. So we are measuring some students and we find that there's a bimodal distribution, but when we look closer, we see that there were actually two different schools represented in our distribution. And we know that one school tends to be more high performing, the other more low performing. And when we separate out those students who are going to one or the other school, we find one distribution for the low performing, one distribution for the high performing. We put them all together in the same data set, we have a bimodal distribution. So those are the two times when we might find bimodality in our distribution. Let's practice this with a simple data set. When you're looking for the mode, we're looking for the most frequently occurring score. And so for data set A, what score would that be? There are more 4s in this data set than any other score. And so this is a unimodal distribution, the mode being 4. How about for data set B? Well, there are actually 2 modes. We have one mode at 5 and a second mode at 9. This is a bimodal distribution. In a bimodal distribution, we do tend to report the lower of the 2 modes if we have to pick one. So what are the characteristics of the mode? We use the mode most often with nominal data, or if we have scale data that has more than one mode. It's not normally distributed. The reason why we might choose the mode is because it is not susceptible to outliers. If you add a very large score to our distribution, it doesn't touch the mode at all. It is a quick and easy measure of central tendency, although it may not be a good idea, may not be a good measure if the behavior that we're measuring is 0. If I ask you, how many cigars have you smoked in the last month? And I go around the room, most people say 0. I might have a handful of people, 1 or 2 people that say 2 or 3. The most commonly occurring score is 0. And so we don't really learn very much about the distribution from that mode of 0. We'd probably want to use a different type of measure. So our second measure of central tendency is called the median. You're familiar with medians if you drive. You've seen a median in the middle of the road. Well, a median score is in the middle of the distribution. We can think of it as the geographic center of the distribution. If I tell you that the median is 10 in this distribution, that means that exactly half of the scores are above 10 and half of the scores are below 10. We could compute a median using data sets, but the most important thing to keep in mind when you compute a median is that, number one, you must put the scores in ascending order, starting with the lowest score in order to the highest score. Now, having done that, we look for the middle number in our distribution. If we have an odd number of scores, this is very easy. The median is located in the n plus 1 divided by 2 position. If we have 7 scores, then n plus 1 would be 8, divided by 2 would be 4. The 4th score is the median. In this case, it's a 3. But if we have an even number of scores, then we split the upper and lower halves, and then we would take the average of the middle 2 scores. So in this example, we have a 12 and a 13 in the middle. We would say that our median is 12.5, halfway between the 2 middle scores. What are the characteristics of the median? We will prefer to use the median when we have data at the ordinal level that we can arrange in an ascending order. We might also use the median when we have scale level data that are highly skewed. The outlier is pulling the distribution out in one direction that would affect the mean or the average, and so we'll use the median to give us a more representative score. But the median is not going to be useful with nominal data. Can you think of why that would be? What's the very first thing we need to do when we calculate a median? Put the scores in ascending order. With categorical variables, the variable that has an underlying order is the ordinal variable. Nominal variables don't have an underlying order. So we can't put them in order, can't really use a median, doesn't really make sense. Another advantage is that we can have only one median, whereas we could have two modes. So it's just going to be simpler and easier to report the median. And finally, the median may not actually be one of the scores in our distribution. As we saw in that last example, the median was 12.5, the average of the two middle numbers, even though the number 12.5 didn't appear in our distribution. The third measure of central tendency that we will explore is called the mean. Now, the mean is the mathematical center of the distribution. It's most commonly used with scale level data. Remember, interval and ratio level data. And it's the score that is most likely to be called an average. It is true that a mode and a median could also be called an average. But when you use the word average, most people are going to assume that you're talking about a mean. So this would be important. If you have chosen to use the median because your data are skewed, you could call it an average, but you need to be specific that you've used the median. Otherwise, people might think you were using the mean, and that would be deceptive in the way that you are displaying your data. In a normal distribution, a bell-shaped curve, the mean, the median, and the mode are exactly the same. When you see mean, median, and mode very close together, you can generally assume that that will be a normally distributed data set. Now, I told you that the mean is the mathematical center of the distribution. We should then consider what is the mathematical formula that we would use to calculate the mean. And it's pretty simple. We add up all of the scores, and then we divide by the total number of scores. In this formula, the thing that looks like a giant E, that is the sign sigma, capital sigma, means add up the scores that follow. X are the raw values in the data set. So this is the sum of X divided by N, which would be the number of scores or people or cases in our data set. Sum of X divided by N equals the mean. Now the mean can be represented either by a capital M or by an X with a bar over the top. Anything that has a bar over it means that it is a mean. If you see Y bar, that's the mean of Y. Z bar would be the mean of Z. But most commonly, we call our scores X scores, and we use the mean of X, or X bar, to stand for the mean. The characteristics of the mean: the variables must be at the scale level, interval or ratio, in order to use the mean. And although we can calculate the mean of skewed data, we should be cautious about reporting that mean, or at least report the mean along with the median. It is useful for planning. Let's say that we know that our community is going to grow by 1,000 families in the next 5 years. And we know that the average family has 2.3 children. There are no families that you know that actually have 2.3 children, but that 2.3 is useful for planning. If we know that we're going to grow by 1,000 families in the next 5 years, each family has 2.3 children on average, we can then calculate how many public school classroom seats we're going to need to add over the next 5 years to accommodate the growth in our community. Even though no individual family has the mean number of children, knowing the mean can be useful for planning for the future. And although the mean is relatively stable, it is susceptible to outliers. If we have outliers, we need to consider other measures of central tendency and perhaps report them if they are a better estimator of the actual center of the distribution. So that's the mean. But there's more than one kind of mean. In fact, there's a mean for all seasons. Many more means that we could explore, and let me show you a few of them. The first way that we might want to adjust our mean is if we have outliers. The outliers are going to pull the mean out in the direction of the outlier, and one way to deal with that is to use a 5% trimmed mean. That means that we take our distribution and simply trim off the upper and lower 5% of scores. We would then take the average, or the mean, of the middle 90%, giving us a mean that is much more representative of the remaining scores in our distribution. A second way that we might want to adjust our mean would occur if we are measuring prices. However, what we are purchasing varies. And so we might be purchasing more or fewer items as that price continues to fluctuate. Therefore, we would use a weighted mean. We would weight the price by the number of purchases. So as you look at this table, over 4 weeks, we've been making gasoline purchases. The price of gas has gone up and gone down as it fluctuates. Well, we've also been purchasing different numbers of gallons of gasoline each week. So what we have done is used a formula to weight the purchases for a particular week and then get an average of the weighted mean, which we would find to be much more representative of the actual average cost of gas based on how much we were purchasing. A third way that we might adjust the mean would occur if we have scores that increase or decrease, fluctuate based upon characteristics within the data. This is called a geometric mean, and it's most commonly used with financial data, where your overall rate of return is going to be affected by the ups and downs of the market. I have also used this particular type of mean in a case working with a hospital when we were examining average admissions. The hospital has a certain number of beds, and if the hospital discharges 10 patients on Friday, that means there are 10 available beds for intakes over the weekend. But if only 2 people get discharged, there's only 2 beds available, that will limit the number of intakes. So number of intakes was also a function of the number of discharges. And in that case, we used a geometric mean to adjust for those fluctuations, giving us a much more accurate mean to use than for our predictions and for our planning. Well, now that we know a little bit about central tendency or measures of location, let's figure out how to do this in Excel. For this example, I have given you a data set. It's the same dog toys data set that we have been using all along. In this case, I created a special version, which is for week 5. That's available on Blackboard. If you're using a version that you've downloaded from the Google Drive on YouTube, you can just use the first page of that data and follow along with that. As we look at the data set, all of the data for the full dog toys data set are on tab 1. On the second tab, I've created a place where we can just look at our scale variable and create the measures of central tendency. So on this second tab, we see the numbers, the identifier for the dogs, 1 through 50, and only the scale variable, days to fail. This was the example where, as a thank you for participating in the survey, the dogs got to choose a toy, and then we kept track of how long it took for them to chew the stuffings out of that toy. That is the days to failure for that toy. Scale variable, let's create the measures of central tendency. We are going to create the formulas for our measures of central tendency in the blue boxes where it says values. And then those formulas will appear in the orange boxes underneath the tab where it says formulas. We're going to start with the mean. So let's put our cursor in F2 and we can create our first formula. Remember, formulas always begin with an equal sign. So we will type equal sign. The value or the formula for mean is average. You can use either lowercase or uppercase. When you hit return or enter on your keyboard, Excel will change the lowercase to uppercase, so you can use either one. So we type average and then open parentheses, and we need to enter the range of our data. Our data range from B2 to B51. So let's start by typing B2, and then let's make this an absolute reference. If you're using a PC, type F4. If you're using a Mac like I am, it would be Command T. The dollar signs indicate that this is an absolute reference. If we drag or change this formula, the reference to B2 will stay consistent. Now type colon and B51. Use the same F4 or Command T to make this an absolute reference, and close parentheses. Click Enter or Return, and we have created our first formula. The value for the mean is a 9.0. Why did I create absolute references? Well, I'm going to show you because I'm going to take a shortcut. Click on F2, where we have created our formula for the average, and drag it down to the fourth box where it says geometric mean. Now, I've just copied the average formula right down the line, but that means I can change just the formula itself and keep the references to the data the same. I'm just taking a little shortcut here. We're next going to use a formula for the median. Well, the median is median. And when you've typed median and hit return, we now see the median of 8.5. For the mode, it's not as simple as typing mode. This is a single mode. So we would type mode.sngl. This gives us a single mode, and that value is 8.0. Our mean, median, and mode are 9, 8.5, and 8.0. Those are fairly similar values, and we can assume from that that this is a fairly normally distributed distribution. If the mean and the median were quite different from each other, that would indicate outliers or skew in either the positive or negative direction. Well, we have one more measure of central tendency to compute, that is the geometric mean. Now, when we computed the mean, we used the word average. However, for the geometric mean, it's simply geomean. And this will give us a value of 7.8. This is not a data set in which we would typically use a geometric mean. My purpose here was to show you how it would be done if you had the kind of data for which you would use a geometric mean. Now, before we go on, I also want to show you how to create measures of central tendency in JASP. You will recall that JASP does not open an Excel data set. That's all right. What we're going to do is open the data on sheet 1 of our Dog Toys 2 data set, and we will save it as a CSV. We open our data set in Excel, we go to File, Save As, and we will save our data on sheet 1 as a CSV, comma separated values or comma delimited file. We just save it to the desktop. Once that CSV has been created on the desktop, we can open it in JASP. So we've opened the JASP program, go to the main menu, and click on Main Menu, Open, Computer, Desktop. Click on that Dog Toys dataset, and it will open the data in JASP. Once the dataset has opened, we're going to use the Descriptives menu. Click on Descriptives, it opens our options for descriptive statistics. We're going to use 3 variables. For this example, we're going to use a scale, an ordinal, and a nominal variable. Let's use the scale variable days to fail. We can just drag and drop that from our list into the variables box. For the ordinal variable, we'll use dog size. Click on dog size and then the triangle in between the 2 boxes. We can also move the variable that way. Sometimes we can double click on a variable to move it, but we can't do that with our categorical variable favorite toy. You notice that based on the grayed out icons, we could put favorite toy in the split box, and that would split our analysis by type of toy. Not what we want to do here. So what we have to do is, let's say, drag and drop favorite toy into the variables box. Now we have 3 variables: days to fail, which is scale, dog size, which is ordinal, and favorite toy, which is nominal. We're already seeing some basic descriptive statistics in our results pane, but we want more options. So let's open up the statistics options, just twirl that open, and we see that there are measures of central tendency available to us. We have the mean, the median, and the mode. We could use the sum as a measure of central tendency, but we're not going to use that now. For this example, I want to uncheck the standard deviation option under dispersion. Now let's take a look at the resulting table. And we'll pay attention to which measures of central tendency are useful with which levels of measurement. I want to actually focus for the moment on the minimum and maximum scores. So for days to fail, we see the minimum is 1 and the maximum is 20. This is a scale variable. It ranges from 1 to 20. The mean is 8.98, the median is 8.5, and the mode is 8.0. Again, a roughly normally distributed variable. The mean, median, and mode all make sense for this variable. But now let's look at our ordinal variable for dog size. The minimum is 1 and the maximum is 3. There's just 3 categories. So does an average of 2.4 make sense when what we're really averaging is small, medium, and large? The mean is not useful with our ordinal variable, nor is the median. The mode would be useful with this ordinal variable. It tells us that whatever is coded as 2, which in this case would be the medium size, that's the most frequently occurring category. Same pattern with our nominal variable. The mean of 3.14 out of 5 categories isn't useful, nor is the median, but we do see that whatever was coded as number 5 would be the mode. With categorical variables, the best way to display the descriptive statistics would be to check the frequency tables for nominal and ordinal variables. That will add a frequency table that gives us the levels of measurement, or rather the levels of the variable, much more useful for a categorical variable. So that is how we would create our measures of central tendency, both for Excel and for JASP. And you can feel free to use the program that works best for you and your research project. But before we go, I do want to make sure that we save this data set not as a CSV, but as a JASP file that we can reopen and we can save all of the work that we've already done. So we will do that by going to the main menu, Save As, Computer, Desktop. And we will save our data as Dog Toys 2 to the desktop, click Save. And now we have a JASP formatted file that if we were to close JASP, we could double click on this file and it would open up JASP and it would open up our data set. So that's everything that we're going to learn about central tendency for now. I have a second video coming up talking about variability, and my coworker is going to get back to doing some serious napping. So I will see you in that second video.